how our device is supposed to be. It has a wrist unit, 5 rings, and 5 fingernail units. So the wrist unit will have an Arduino that lights up the rings for 50 milliseconds at a time and record the data of all the sensors, creating a 15 by 15 matrix. The fingernail that are close to it will get triggered and send a pulse modulated light at a certain frequency, giving an additional 10 columns to the matrix, and this data will then be sent to the computer through an XB module. The data will then be used to train the neural networks and give an audio output of the letter being signed.
Fabrication of the ring units start by 3D printing the rings in ABS. Using these rings, silicon molds were made alongside with the ring PCB placeholders. After the molds have been created, we can proceed to resin cast the ring unit. The first step of casting is to fill the mold halfway with resin and then insert the ring placeholder molds into it. Once the resin has cured, the placeholder is removed and the PCBs are inserted into the resin. The placeholder mold ensures that the PCBs are placed equidistantly. The latter half of the mold is then filled with resin and left to cure. This results in the final ring design.
This is the fingernail unit. It is resin printed. Ideally, it will have a double-sided PCB with an emitter and receiver pair on both sides, where the emitter will produce a modulated light at a certain frequency when triggered by the receiver and powered by 3 SR60 batteries in it.
We intended to ideally use this 5-5 timer oscillator with a square 2 sine wave filter for our final design, since it allows us to precisely control the output frequency. We have been able to differentiate between 156 and 234 Hz signals using a fast Fourier transform algorithmic on the Arduino microcontroller board. Unfortunately, since the current circuit consumes 80 milliamperes when operating, we have chosen another device which can be built using a TPL5111 power gating chip, consuming only 5 milliamperes when operating and less than 10 microamperes on standby mode. This is the TPL5111 timer gating chip circuit. When I turn this circuit on, it will stay on for a set amount of time set by the resistor. In this case, it will be 2 seconds. Then it will turn off and stay off until activated again by an IR LED light. When this circuit is activated, it will blink 2 LED lights at that set frequency set by the resistor. Here you can see the frequencies. When the IR LED light stops triggering the circuit, it will stay on for 2 seconds and then turn off until activated again.
So these are the 2 rings that we managed to fabricate before spring break. There are 3 PCB on each ring, and each PCB has an emitter and receiver pair. Unfortunately, one of the PCB does not work, so we have added a wrist-based beacon to compensate for that board. So overall, there are 6 working emitter and receiver pair. This is open, partially open, and this is closed.